Let us see this question. See, when we solve this logarithmic equation, to find the value of x is an easy task. But at the end, most of the students forget to verify the answer with respect to the restrictions on the value of argument and base. So after solving this, whenever we will get the value of x, stop and think that is this x a valid solution or not? That is very important. Let us say this. See, there is a sign of subtraction between two logarithms. So we can use this rule. Log A minus log B is equal to log A by B. It is an easy task now. So just assume that this 6x is A and this x minus 1 is B. Just go ahead and you will get the answer. I'm finishing it over here. So log A by B, that is 6x by x minus 1, is equal to log 12. So we can compare the arguments over here. So by comparison, we get this. Do not say that dividing both the sides by log. No, you cannot divide the both sides by log. So 6x is equal to 12 times x minus 1. So we get 6x is equal to 12x minus 12. So minus 6x is minus 12. So x is 2. Yeah. X is 2. Now let us check the validity of this x. One of the argument is 6x. That is 6 times 2. That is 12. It is greater than 0. So accepted argument. Perfect. This one, x minus 1. We have to check both. Okay. 2 minus 1. 2 minus 1 is 1. 1 is greater than 0. So it is accepted. Yes, this is an accepted answer. If you want, you can try this question. If you have tried this, then you should get x is equal to 4. Okay, here I am solving this. I should use this quotient rule. Log A minus log B is equal to log A by B. Okay. So if I use this rule, then log 5x over x minus 2 is equal to log 10. Let us compare this. So by comparison, we get this. Cross multiplication, 10 times x minus 2 is 5x. So 10x minus 20 is equal to 5x. Collect x on left and numbers on right. So 10x minus 5x is equal to 20. So 5x is 20. So x is 4. Let us check the validity. This argument 5x, 5 times 4, that is 20. It is greater than 0, so accepted. But we have to verify at both the arguments, okay? X minus 2 is 4 minus 2, that is 2. It is greater than 0, therefore x equal to 4 is accepted. Great. Not difficult at all. Please try this question. Again, there is a sign of minus between these two terms of logarithm. So we have this log A minus log B is equal to log A by B. Okay. So I get log x plus 3 over x minus 1 is equal to log 4. So by comparison, I get x plus 3 over x minus 1 is 4. So x plus 3 is 4x minus 4. Collect x on left, numbers on right. So negative 3x is negative 7, 7 only. So x is 7 by 3. Yes. Fractions are fine. Yeah, no problem. Now let us check the validity of this solution. The first argument is x plus 3. So 7 by 3 plus 3 will be greater than 0, right? Both are positive, so greater than 0. Now x minus 1. 7 by 3 minus 1. That gives me 4 by 3 and it is a positive number, so accept it, right? Therefore, x equal to 7 by 3 is a valid answer, right? Valid solution. So here we are developing our habit that all the solutions must be checked with respect to this argument. And in future, we will check the base of logarithm also. Okay. So here we have variables on the both sides, yeah. Even over here we have x. So there are the chances of getting a quadratic over here. So whenever the quadratic is there, we may get two values, right? And then the validity checking will be a lengthier process. Okay, let me do it. So here nothing but log A minus log B. So I can apply log A minus log B is log A by B. Log A by B, right, is equal to log x. Now we can compare the arguments on the both sides. So by comparison, I get x plus 3 by x minus 1 is equal to x. We can do the cross multiplication. X times x minus 1 is equal to x plus 3. So x square minus x is equal to x plus 3. Let us collect everything on the left. So I have x squared minus 2x minus 3 is equal to 0. It is a quadratic equation, right? So please use your calculator and find the roots. So if I use my calculator, it gives me 3 and negative 1. Now let us check the validity of this one. For x is equal to 3. The first argument is x plus 3. X is 3 plus 3, that is 6. It is greater than 0. Perfect. X minus 1. X is 3. 3 minus 1, that is 2. It is greater than 0. Therefore, x equal to 3 is accepted. Perfect. Now for x is equal to negative 1. Do not reject it, okay, without validating. X plus 3. X is negative 1 plus 3, that is 2. Yes, it is positive. Here, x minus 1. X is negative 1 minus 1. So it is minus 2. It is less than 0. Therefore, here you should write that argument of the logarithm must be positive number. And here x equal to -1 gives us negative argument. That is why x equal to -1 is not accepted. Okay. The argument must have positive value, right? Therefore, x equal to -1 is not accepted. So our full and final answer, x is equal to 3. Great. It is a merit level question, my dear students. Please do not miss this section. Whenever students get answers, they become happy. You should. But over here, I want you to become happy. But here, not here. Okay? Now it is your responsibility to try this question, my dear students. Please pause the video and try it out. Okay, if you have tried, then the answer would be x is equal to 4. Okay, if you got the correct answer, please move to the next question. Here I am solving it. Log A minus log B is nothing but log A by B. A by B is equal to log x plus 1. Perfect. We can compare the arguments when the bases are equal. Let me clarify what I want to say here. Here x is not equal to 5, my dear students, because the base are different. And the base is different, the logarithm has different values. So here you cannot say that x is 5. No. But here in our case, no base is written. That means the base is 10 everywhere. So we can compare them. So I have x plus 6 over x minus 2 is equal to x plus 1. We can cross multiply these over here. So we get x minus 2 times x plus 1 is equal to x plus 6. So x times x plus 1 minus 2 times x plus 1 is equal to x plus 6. Okay. So we get x squared plus x minus 2x minus 2. Let us bring everything on left. That would be better for us. X cancel. Good. X squared minus 2x minus 8 is equal to 0. Yes. Minus 2 and this minus 2 and minus 6 is minus 8. It is a simple quadratic equation. You can solve it. So using your calculator, you will get 4 and 4 to the 8. So it is negative 2. Now let us check the validity. So for x is equal to 4, there are 3 arguments, x plus 6, 4 plus 6, that is 10. It is positive. Okay, move ahead. X minus 2, 4 minus 2, that is 2, is greater than 0. Yes, move ahead. X plus 1, that is 4 plus 1, that is 5, greater than 0. So therefore, x equal to 4 is accepted. Okay, now let us check for x equal to -2. Okay, so x plus 6. X is -2 plus 6, so it is 4. 4 is greater than 0. Yes, move ahead. X minus 2. X is -2. And this is -2. So it is -4. That is less than 0. Therefore, x equal to -2 is not accepted because it is generating a negative argument. Okay. Therefore, x is equal to -2 is not accepted. Good. Here you can write the argument as we are writing everywhere. The argument of logarithm must be a positive number. Due to this x equal to -2, it is becoming a negative. That's why it is not accepted. You should write this everywhere. So the final solution is x is equal to 4. See what is happening here. For this negative value, it is being rejected. But this will not be the case always, because if the bracket is something like this, 1 minus x, okay? If the bracket is like this, then 1 minus -2, that will give you a positive argument, right? So always do not reject the negative value blindly. Take a wise decision. Invest time in calculating. Okay. Next. Oh, I think it is the same type of question I would have kept for your practice. So why don't you practice now? Pause the video, please, and try it out. Okay, if you have tried, then you should get x is equal to 5. Let me solve it over here. Here it is nothing but log a minus log b. Okay, so log a minus log b is nothing but log a by b, x plus 1 over x minus 3 is equal to log x minus 2. Perfect. Now we can compare the arguments over here. X plus 1 over x minus 3 is equal to x minus 2. We can go for the cross multiplication over here. So that is x minus 2, x minus 3 is equal to x plus 1. Perfect. Let us multiply these two brackets. X times x minus 3 minus 2 times x minus 3 is equal to x plus 1. So I get x squared minus 3x minus 2x plus 6. Send it on left. Minus x minus 1 is equal to 0. We are getting a quadratic. X squared minus how many x? Minus 3, minus 2, minus 5, and minus 1 is minus 6x. And the number is plus 6 minus 1, that is plus 5. Oh, my dear students, these are real classroom videos, so I have to calculate in front of you. I am not the YouTuber that who keeps everything ready and they just wrap up everything. No, I'm calculating everything in this live session, so it takes time. I have to calculate everything. So if you use calculator, we get two answers like x equal to 5 and x is equal to 1. Both are positive this time. Yeah. That is why I'm interested in this question. Both values are positive. So now let us check the validity of these answers. For x is equal to 5. Let us see what happens. X plus 1. 5 plus 1. That is 6. It is positive. Okay, go ahead. X minus 3. 5 minus 3, that is 2. It is also positive. Go ahead. X minus 2, 5 minus 2, that is 3. It is also accepted. Therefore, x equal to 5 is accepted. Cool. Okay. Now let us check for x equal to 1. For x is equal to 1, let us see what happens. X plus 1, this x plus 1. 1 plus 1, that is 2. It is positive. Okay, 2. X minus 3. X is 1. 1 minus 3, that is negative 2. It is less than 0. Therefore, so what I can write here, for x is equal to 1, the argument of log becomes a negative number. That is not accepted, right? Okay, so x equal to 1 is not accepted, right? Therefore, x is not equal to 1. So the final answer, the solution of the equation is x equal to 5. Okay. So it is not necessary that when x is negative, it is rejected. And it is also not necessary that when two values are there and the smaller one is rejected. No, it is not like that. Okay. Sometime it will happen that the bigger number will be rejected. Okay. So that is why we have to keep ourselves in the habit of validating our obtained solutions. See, if you will not do these calculations, no, you will not get marks for this question. Oh, 2 to the power x. Yes, we have a new rule of logarithm. The rule is something like log A, B, and C. You have to understand and fill the positions of these all three, A, B, and C. This A is at base, right? Is base. This B is the argument, right? And C is the power of B. This is very different than whatever written here. Okay. This is not equal to this. Here, this power is applied to B only. And here, the power is applied to everything. Okay. And we have the rule for this only, not for this. Please take care. And the rule is, you can bring this power here in front. So you get C times log B with base A. Simple. Bring the power in front. But if the power is applied to everything, do not bring it. Okay. So here, the power is applied, this x is applied to this 2 only, right? So I can bring that x in front. So basically, it is written like this: log 2 to the power x is equal to log 32. Okay. So according to this rule, we can bring this x over here in front. So x times log 2 is equal to log 32. Right? Now, from here, you can find the value of x. Okay? X is log 32 or log 2, please use your calculator. You will get an amazing answer, and that is 5. Okay. Actually, I just explained everything, but it is not required. Yeah. What can be done? You can just compare these arguments over here. So if you will compare the arguments, 2 to the power x is 32, right? Yes. And what is 32? 2 times 2 times 2 times 2 times 2. So 32 is nothing but 2 raised to 5. So by comparison, you can get x is equal to 5. Perfect. Yeah. But on the place of 32, if there is a 7, then how will you do this? You have to follow this method. Okay. So wait for this. Okay, wait for this 2 raised to 7, 2 raised to x. Yeah. I will explain this question. Oh, my dear students, what is important for us? You cannot bring this c in front. Here you can, because this c is the power of b. It is the power of the argument. If it is the power of argument, you can bring it in front. But if the power is applied to everything, you cannot. Okay. So here what I was explaining is, by comparison, you can get the value of x. Okay. But if the question is something like this, log 2 raised to x is equal to log 7. Okay. And then you compare 2 raised to x is equal to 7. How will you get the value of x? No, not possible, right? Instead, the story is absolutely opposite. If this will be the question, then we will do something like this. Okay. Let me show it to you now. Here. Find x. 2 raised to x is equal to 7. Yes, we want to find the value of x. If on the place of 7 there is 8, the task is very easy. 8 is nothing but 2 cubed. So x is equal to 3, right? But in our question, the problem is 7, not 8. Yeah, big problem. So log was developed to handle this question, my dear students. Okay. The whole concept of logarithm was developed to handle this kind of equations and problems. So what we do in this case, we apply logarithm on both sides. We apply log on both sides. 2 to the power x, 7. Now this x can be brought here in front. So x is log 2 is equal to log 7. I can send this log 2 in the denominator of the opposite side, log 2. And here it is log 7. You can insert this in your calculator. Oh, my dear students, if you are confused, then let me tell you. If you have log 7 minus log 2, you can write log 7 by 2, right? But here it is not the case. It is log 7 divided by log 2. So you have to insert this in your calculator and whatever it gives, Just be happy with that. So log 7 divided by log 2. So here x is approximately 2.807. Okay, there are many digits after this. Let us verify our answer. Everything is fine now. 2 raised to x. 2 raised to this. Okay. I'm using my calculator. 2 raised to 2.807354922. So I'm getting exactly 7. Yeah. Okay. Great. So logarithm was developed to handle these kind of questions. If x is in the power, to bring it down in front of here, this, you have to apply logarithm on both sides. So you can bring the x down and you can easily find x. And I have seen many students getting confused between this and this. It is log 7 divided by log 2. We don't have any rule for this. This is that. Okay. Let me explain you one more question of this type. And I will take a familiar value so you will get some confidence. Okay. 5 cube is 125, right? I'm taking the example 5 raised to x is 125. Then what is the value of x? We know the answer. 5 cube is 125. But I want to teach you this method, how it can be used. Okay? You should apply logarithm on both sides. By application of logarithm, this power can be brought here. Okay? So we have x log 5 and it is log 125. So x is equal to log 125 by log 5. If you use calculator for this right side, you will get x is equal to 3. Great. Okay. So whenever this variable x is in the power, to bring it down on the floor, okay, apply logarithm on both sides. That is the best technique to handle these questions. I am ready with many questions to give you the practice. So we will continue with the same process of using the basic rules of logarithm, and from the next lesson I will be mixing all the rules, addition, subtraction, powers, everything. Okay, so whatever we have done, please keep it revised. See you then. Goodbye.